In this video, we're going to look at the last two types of heat transfer. We already looked at conduction, so the next one we're going to look at is how heat moves through a liquid and a gas. It's going to move through them in the same way. The first thing we need to keep in mind is that when something heats up, what's really happening is the molecules in that substance begin to move faster. So if I've got slow movement here, but fast movement down here, what's going to happen? What's going to be the difference between these two things? Well, because these are moving faster, they're able to move apart more and make more space in between these molecules. So if these two move really fast past each other, then there's going to be a lot of space. When there's a lot of space between those molecules, it becomes less dense and it's able to move upwards. This is the basis for how heat transfer moves in a liquid and a gas. We're going to look at an example of that. Okay, in this demonstration, I've got a nice big tub filled with water suspended on some mason jars here. I'm going to take this mason jar and I'm going to fill it up with very hot water and place it right under here, right under the middle of this tub. I'm going to take food dye, place some red food dye right here, some blue food dye on either side, and what we're going to see is the hot water in here will heat up the water above it, and we'll be able to see the convection currents that are created. Okay? Okay, first let's place our cold drops. And let's place our warm. Okay. So we've got a nice pile of food coloring on the bottom. And now we just need to put the mason jar in place. So with this demonstration, we can see that as a heat source heats a fluid, whether that is a liquid or a gas, it'll cause that fluid to get warmer, which will allow it to expand and rise. So the part that's getting heated rises up, right? And then the part that is not getting heated, so the part that is colder, is going to move in to replace the part that rose up. So you get this natural flow within the fluid. Again, whether that's a gas or a liquid. So we see this very easily in cooking. If you ever boil some noodles, you don't have to stir the pot of water because it naturally stirs itself. So it gets very even heating throughout the entire pot. This is also how things like wind work. As the sun heats the surface of the earth, the hot air rises and cold air moves in to replace it. As that air moves, it creates wind. It's a cold and windy day here in Wisconsin, and my neighbor has the heat control in her apartment downstairs. But that's okay, because I have this gas fireplace. This thing is able to heat up my entire apartment pretty quickly, actually. If I've got it on full blast, within the hour, it'll be blistering in here. Why is that, though? I mean, we learned about convection currents. According to convection currents, shouldn't this all rise? If I have this fire going, the air inside should start rising up and travel through the chimney and just leave. Why does the energy radiate out into my apartment? Well, that's the word, radiate. The term for this final third type of heat transfer is radiation. When we have a heat source like a fire, let's just write fires because I don't want to draw one, I'm generally not good at it. If I've got a fire here, the heat that it lets out, remember it's being let out because of the process of combustion. Even this right here is our CH4 plus O2 creates CO2, H2O plus heat. That heat is going to go in all directions. So as this fire goes, the heat goes upwards, goes to the side, it's going to go down even, all over the place. Why does it rise then? Why does it get so much hotter above the flame? Well, quite simply, as soon as this heat radiates out from the fire, it's going to run into air molecules and it's going to let them have some of that energy. So the air around the fire absorbs that heat and that air then travels upwards. So we get these convection currents going up. So the hottest place around the fire is going to be the top of it, right above it, because not only are we getting the heat from the fire radiating up, we're also getting the heat from all the air that's absorbing that energy. But it doesn't absorb all the energy. And that's why if you sit near a fire, it's a little smiley face, that's you, right there. If you sit by that fire, some of that heat energy is going to come out and hit you. Everything that has a temperature, which is everything, radiates some amount of heat all the time. Radiation is how that energy is able to move through empty space. It doesn't have to go through a solid, it doesn't have to go through a liquid or a gas. Even if you're out in the vacuum of space, some of your energy will radiate away from you. This is how most of the energy from the sun gets to the earth. It's radiation through space. So if we have a little drawing of the sun here, sun, it radiates its energy to hit the earth. And that energy warms the surface of the planet. So when we have any heat source, it gives off that heat as energy. The specific name for that often is infrared energy, is infrared radiation. It's slightly less energy than the light that we can see. But when we wear infrared goggles, that's the type of light wave that you're looking at. It's the infrared spectrum. So now that we've looked at the different types of heat transfer, we should be able to finish up that worksheet, and then we'll be able to move on to understanding why heat moves the way that it does, and why certain reactions can actually get colder instead of hotter. To review, we looked at conduction, which is how heat and energy move through a solid piece of material. They're going to move straight through from the heat source through the material at a steady pace. We learned about convection, which is how heat and energy are going to move through a liquid or a gas, either one. We learned that from the heat source, the liquid and the gas will become less dense and they'll move upwards. And then the colder liquid or gas will move in down to the heat source because they are more dense. And we learned about radiation, which is any heat source is going to radiate energy in all directions. So this is the heat source right here. This is the heat source. And it radiates that energy in all directions. Okay.